I would like to welcome Mr. Aaron Davis from Kew Gardens.
Am I on? Yes, yes. Good morning, ladies and gentlemen, distinguished guests. As Stefan said, I am a botanist, and I lead the Kew's Crops and Global Change team at Kew, but my research focus, of course, is coffee. And I want to talk today about the future of coffee from a plant perspective. And I want to start with, of course, some context to really put people, the audience, those gathered here, in the picture. So I think the first question is, what do I mean by orthodoxy? I think there are two orthodoxies. One is that we will always use the same crop species forever and ever, including coffee. And that's just not the case. History tells us that it's fluid. Not on a yearly basis or a decadal, but on a generational basis, on a century-wide basis, things change. But the main orthodoxy I want to really, I suppose, challenge today is that Arabica and Robusta will provide us with the climate change adaptation solution that we're so much hoping to find. And you only have to look across the internet of recent times to see some of the stories and some of the news items and press releases around climate-resilient coffees. And there's one here from Starbucks. When you read the text, it sounds wonderful. And the same goes for Robusta. I think Robusta is even worse in the fact there's so much misinformation out there about Robusta and about its ability to be future-proof. If you look at the science, if you look at the evidence, it's just not there unless you're going to bring in substantial portion of the genome from something else. Now, there are over 200 studies on the impact of climate change on coffee. None of them provide good news, right? And they're of a variable quality. Some are very good, some aren't so great. But I think the problem is that matching expectations in Arabica and Robusta with the climate change projections just do not make any sense. So if we look at here some very simple climate profiles for some of the commonly cultivated species, you'll see that you'll need to have a profound shift in the biological characteristics and the climate potential of those species. So we're talking, we need a 4 degrees Celsius shift in annual mean temperature for Arabica to be really viable as a medium to long-term solution to climate change. And that's just one parameter, right? That's just temperature. Species have their limits, they have their boundaries. You cannot keep altering species without doing something very, very profound to provide a climate-resilient solution. So the question is, what do we do? And there are 3 main pathways for resilience. I won't go over those here, but changing the crop itself is probably going to be the most successful and least disruptive and most cost-effective. So what do we mean by the other species? So we have officially we have 130 coffee species in the wild. I'm talking about wild species. And I must make it very clear, I'm not talking about varieties, these are species. Arabica and Robusta and Liberica are species, etc., etc. So we have 130 species, so unlike other crops, we have a lot of potential, right? We have a lot of genetic diversity, a species diversity with which to play with. I think the first question here is, where do we start? 130 species, which one should we start? Well, we already have 9 taxa, 9 species in cultivation that are being used to produce coffee. However, Arabica and Robusta provide us with more than 99.9% of the coffee we drink, and those other species are almost insignificant. So if you look on the web, you'll see Liberica providing us with 2% or even 1% of global production. That's utter nonsense. So our focus, we're looking at all coffee species. Our focus at the moment, in particular, are 3 species, or 1 species with 2 varieties: the Excelsa coffee, Liberica coffee, and stenophylla coffee. There are these other species, and you'll see a lot of information on the internet. These are the next crop species. They're just not, right? Because they are produce very little coffee per tree, per hectare, very low yields, and they all have very small beans, like the size of a small lentil. But they do have potential for coffee breeding. This is a trip I made to northern Mozambique in 2019, looking at Racemosa and Zangobarii. This was a lovely canoe trip to this Carimbus island. 42 degrees on that day, very, very hot, very, very dry. I'm on the beach, just got out of the canoe, turn around. On the beach is Ibu coffee. Coffee is at Zangobarii. 4 months dry season, almost no rain. This is in pure sand. Arabica and Robusta, just, they wouldn't survive 5 minutes here. It's a huge, huge potential. Unfortunately, it's not a commercial species, but it does have that genomic versatility to be used in breeding studies. Now, if we look at that species, Ibu Coffea Zangobarii, we can see that it grows in the wild and in cultivation. It grows in much hotter, much drier conditions than our commercial species. In 2019-2020, we did quite a bit of work on stenophylla, including a lot of field work, a lot of sort of wild forest work. And we kind of rediscovered stenophylla coffee, which is exciting. But I really wasn't prepared for what this coffee showed us from the research perspective. And firstly, we recollected in 2019. We didn't get seeds, coffee beans until 2020. And we said, look, if this coffee tastes okay, then that's fine. We had low expectations. When we cupped it for the first time, both myself and the head cupper, who was, of course, a Q grader, we wrote down on a pad what we thought. At the end of the cupping, we turned around our pad, and we both said, Red Bourbon, Rwanda, high elevation, more or less. And I was at a stenophylla cupping last year in India, and the Italian barista champion turned around and said to me, we had no discussions beforehand, turned around and said to me on stage, like we're sitting here, and said, Red Bourbon, Rwanda. I was like, wow, and then the hairs stand up on the back of your neck. The other exciting thing is that this coffee will grow under an annual mean temperature that's around 6 degrees, and actually 6.8 degrees Celsius higher than Arabica. So I put here rule breaker, because here we're producing a coffee that's analogous to Arabica, but in a very hot environment and a very seasonal environment. So the orthodoxy, again, is that we have coffee, high-quality coffee is high elevation Arabica, right? But this completely breaks those rules. And we worked with Myriad on this paper as well, and they sent, after that initial tasting, they sent stenophylla to 30 competent judges, and more than 80% of them said, it tastes like Arabica. But I want to focus, I'm not going to talk any more about stenophylla, only that we have around 10,000 plants now in several plots in Sierra Leone, and we're just trying to see, how it's going to perform from an agronomic perspective. But I really want to focus today on Excelsa and Liberica, because here I think we have something that's ready to go and is climate resilient. Now, Kenny Lee will talk about Liberica later on today, so I'm going to focus on Excelsa, because we also have a large project focusing on this species, just to sort of show you the work that we're doing. Now, in 2016, I was in Uganda. I'm looking at the wrong slide. So just for those who don't know Liberica, I'm sure most of you do, this is Liberica coffee, big leaves, big fruits, big seeds, Excelsa, very similar looking. Both are big trees, but it has smaller fruits, smaller seeds. Anyway, I was in Uganda in 2016, and I was asked to go out to some coffee production areas, and I came across a farmer called Ronald, who was growing Excelsa. That, to me, was not so surprising. But then I went back in 2017, we did a survey, we realized there were 200 farms shifting from Robusta to Excelsa, or growing a bit of both. And we had these discussions, and what you realize is that these guys have been producing this coffee for at least a decade, maybe 2 decades, and then it's working for them, right? They're selling it as Robusta, or were at the time selling it as Robusta, but it's disease resistant, pest resistant, drought tolerant, heat tolerant. This is a sack with about 65, 70 kgs of fresh cherry from one tree. 0 inputs, no irrigation, no fertilization, apart from a bit of pig manure. Or they grow peanuts. This is the fruiting branch on the side. Anyway, if anybody wants to look at that in more detail, there's free access to that paper using that link. And then we covered a number of other characteristics, and particularly that the Excelsa bean is similar in size to Arabica and can be processed in a very similar or the same way. You can see the Eugenioides seeds there, they're very small. Ibu coffee and Racemosa coffee are even smaller. You can see the Liberica seeds there, which are much bigger. So once that paper came out, we had a lot more information coming towards us. But before that paper, what we also realized, and this happened concurrently with what was going on in Uganda, is that South Sudan was going for Excelsa in a major way. They have a 1,000-hectare estate, and they have 1,000 Excelsa farmers signed up. And then if you look what's happening across Africa and Asia, Excelsa's starting to re-emerge as a viable crop option. Now, we worked with Volcafe EDF Man in Uganda, and they weren't really that sold on this project, fairly small volumes, maybe 100 metric tons. But in 2022 and 2023, there were some bad droughts. And one of the key things happened there was that the Robusta suffered dramatically. And this is a picture here of a farmer saving his Robusta with emergency irrigation. What you're not seeing here is the Excelsa plants that we planted in 2021, which didn't require any irrigation. And this year, I've been told that they're starting to produce a crop. This is an Excelsa mother tree in Butambala, another Excelsa growing region. And I think this is one of the challenges for Excelsa. It can be a big tree. It has to be capped or religiously pruned. But this is the mother tree, right? This is where they get their seed stock. This tree will produce 300 kgs of fresh cherry. But I think there are 3 very remarkable points about this Excelsa transformation in Uganda, is that it's working as a climate resilient solution. Okay? For farmers. They like growing it, they're selling it as Robusta or as Excelsa, making money. But what they've said to us, this is particularly during the droughts, is that, look, we've been growing Robusta for 200 years. This is a closed chapter for us. It's over. We cannot profitably grow Robusta anymore. And that's why we're shifting to Excelsa. It's not a passion project. It's a matter of survival. The second interesting point is that this is farmer-led. So it's not an academic fantasy by a researcher or scientist. This has been done by the farmers for them to maintain their livelihoods. And the third important point is that this is an indigenous plant to Uganda. This has come from the forests, right? So this is not something that's come from another country. If they didn't have those genetic resources, if they didn't have that species, what would be the fate of those farmers? They cannot grow Arabica. They've never been able to grow Arabica. They can no longer grow Robusta. Excelsa is their only option. So we're working with Coffea. We exported about 10 metric tons this year into the sort of subspeciality market. And I'll talk about the taste at the end of the talk, which is probably what everybody's interested in. So just looking, again, looking forward and looking at challenges, as Christoph said, we need to improve, right? We need to work on these crops. So before I talk about the work, I want to talk about the wonderful collaborations we've had, not only within Q, but also with many other entities, and the funding and the support that we've had from our benefactors. And I think one of the key questions, and this is, we're in the 21st century, we still don't know as much as we need to know about coffee diversity. That's something that's absolutely clear. We don't really know what Liberica coffee is. That's our first research question. And to do that, we're using new generation molecular sequencing, and we're putting a lot of samples into that system. Hopefully, that's maybe 600-700 samples of the Liberica group. And we're using a target sequence capture approach, which captures primarily about 350,000 base pairs, but the washout is about 1 million base pairs. So when I went to the lab and said, look, let's do this Liberica project, and they said, well, look, you've got samples for nearly every other coffee species. Let's do everything. So that's what we did. And I was in the lab on Monday and looked at the progress. We've now sequenced 128 over those 130 species, but in fact, we found through the molecular work there's actually more species, but anyway, so we've nearly sequenced every single species. We've got 2 species missing, which haven't been seen since the mid-19th century. We may not get those. And importantly, I must stress this, is that everything's vouchered. So each of those species that we've sequenced, we can trace back to a specimen, and then trace back to an origin in the wild. And thankfully, molecular biology, sequencing technologies moved along so quickly, we're now not only able to capture a high coverage of species, but also capture a lot of DNA information, which gives us much more precision and much more utility. And with that, we're building this system whereby we will be able to provide a sequence database and other information, including climate profiling, for all species. So if you're in a germplasm collection and you have something you don't know what it is, or you're a farmer, you can put it in the system and you can say with certainty what species that will be. But it's not just about what a plant is, it's about what it does. So we have a lot of field trials for Excelsa in Uganda, run by Dr. Catherine Kawuka, who's doing a fantastic job. So we've got these in Robusta zones, Arabica zones, non-coffee zones. And this is what the trials look like. Nice and orderly, plants growing well. And this is an Excelsa plant, 18 months old, which is now producing fruit. Apart from a few locusts, we've had no issues with pests and diseases. But we're also looking at Excelsa across Africa, along with other species, to get a really good idea of really, the press is like, coffee press is like, we're producing a climate resilient species which is better. What does that mean? That's nonsense, is it? We need metrics, we need imperial measurement. So in all these field trials, we have sophisticated soil measuring equipment in the ground, we measure air temperature, humidity, etc., to understand exactly the parameters we need to understand to make policy and suggestions for farmers and coffee-producing nations. Right, got that out of the way. Now on to the bit that I expect most people might have, have some key questions. What about flavor? And here again, this is another area for where we're trying to make improvements via plant selection and breeding. And this has really been a roller coaster for us. So we started off with Q-grade scores in the 60s, right? Really low. And then we started to improve farm processing, farm management, and we were getting some really nice cupping scores in the low to mid 80s. And this is just one of them from Coffee Nexus, they're a professional sensory company for coffee. And if I hadn't put Excelsa in the title, that could easily be an Arabica profile, right? It's complex, super sweet, mild. That's probably not like Arabica. Quite low in acidity, but I've been very naughty and given this coffee to journalists when they come to visit me, and then they say, well, what's it taste like? And I said, well, you've already drunk it. They said, I didn't notice any difference. And that's exactly where we want to be. This wants to be a commercial coffee. But we're working with this company in India, South Indian Coffee Company, and they are really pushing the boundaries, these guys. So their high elevation Excelsas, this doesn't have a cupping score, but what Union Coffee said is that it was better than any Indian Arabica that tasted. In that cupping session, we had about 20 Indian Arabicas. And I said, well, is it speciality? And they said, well, of course it's speciality. But then we have this score here, right? 88.5, which just totally blew me away. This is from Blue Bottle, but we've put this on tables with, or SICK have put this on tables, All Press and many other places. This is a super sweet, super complex coffee, a little bit like Eugenioid is. Now we talked about safety, so we're following this all up with high-level metabolomic research. So this looks at 1,800 compounds, focusing on 500 for this metabolomic study. And we're looking to see whether we could correspond cupping profiles with metabolomic profiles. What we're also looking for is danger chemicals. So if the Novel Foods Act comes knocking at our door, or anybody else's door, we can say we have the data, there's nothing in here that's at all dangerous, and we do that by comparing it to Arabica and Robusta. And this is just, of course, one compound caffeine. So Excelsa is quite low in caffeine, which is another, I think, bonus point. Just to sum up then, more than 20 years ago, my personal challenge was to understand the diversity of wild coffee species and understand conservation risk. That took a long time. This is a study we published in 2019 where we did the IUCN assessments for all coffee species. At the time, there were 124. I should also say that, that part of that journey in understanding coffee diversity, we had to do a huge amount of fieldwork, including the description of more than 35 new species, which are included in this analysis. But this was 2019, not that long ago, 5 years ago. But with the molecular work, with more field work, we realized that now this is now out of date. We're starting to redo some of the conservation assessments, and it's not good news, right? And to me, this is the major, major challenge. We need those resources to be able to develop coffee, no doubt about that. But if those resources are not there, if that species is extinct, we're just throwing away option after option. And stenophylla, for example, we concluded that if we had waited 10 years, there's a good chance it would have been extinct in Sierra Leone. So we can talk about short-term impediments and issues, but in the long term, if we do not have those genetic resources to begin with, we're in real trouble. And I'm not just talking about the other species, I'm also talking about wild Arabica, wild Robusta. Okay. Thank you very much.